Okay, dear students, the topic under discussion is atomic structure. Atomic structure. Okay, with our previous knowledge about the atom suggests that atom has mainly two parts. Every atom can be classified like this. Atom has nucleus, which contains protons and neutrons, and then shells are present in atom. And in shells, electrons are present. Now in A levels, these shells will be named as principal quantum number. Principal quantum number. This term, principal quantum number, will be used for shells. For example, in an atom, suppose this is nucleus, and this is the first shell. The first shell will be named as principal quantum number 1, right? And this is the second shell. The second shell will be named as principal quantum number 2. This one is third shell. So third shell will be named as principal quantum number 3, and so on. So as you know that shells can be first, can be second, can be third, can be fourth, or so on. So now in A levels, we will term these shells as principal quantum number. We will say that this first shell is actually principal quantum number 1, and the next one is 2, and so on. Right? The other thing which is different in A levels from O levels is the concept of subshells and orbitals. Now we conclude, or the chemists concluded, that shells contains subshells. Subshells actually are present in shells, right? Shells contain subshells, and then subshells contains orbitals, and then orbital contains electrons, right? So if we are to locate or identify electron, so electron can be located in orbital. Orbital will be located in subshell. Subshell will be present in shell, and shell will be present in atoms. So as we discussed just before, that shells can be 1, 2, 3, 4, and so on. Or shells are named as principal quantum number, which can be 1, 2, 3, and 4. Okay, now different shells has different subshells inside. So there are 4 different kinds of subshells which may be present. So the number of different subshells can be 4. One of the subshell is S. The other subshell is P. The other subshell is T. And the last subshell is F. So S, P, D, and F, they represents 4 different subshells, right? So subshells are 4 in number. There are 4 different kinds of subshells, which are S, P, D, and F. Okay. So how these subshells are present in shells and how electrons are arranged in them, for this you have to wait a bit. First, I will explain this orbital, and then we'll come back to this concept of subshell and shells. Okay, so now the concept of orbital. Beta, on paper, orbital is represented with a box. So orbital is represented with a box. With a box. Now this box is just a representation of an orbital. One box represents one orbital, right? So this very box represents an orbital. And maximum 2 electrons can be placed in one orbital. Maximum 2 electrons can be placed in an orbital, right? One orbital can maximum accommodate 2 electrons. And the 2 electrons in one orbital will be placed like this. One of the electron, and this is the other electron. So these are the 2 electrons which can be placed in one orbital. Now the question is that why these 2 electrons are shown with opposite arrows? The question is, why opposite arrows? Or there can be another question, why opposite arrows? Okay, this is the question. Or the other question can be that 2 electrons have same charge. So why can't they repel each other? So 2 electrons having same charge will repel each other. Obviously, identical charge particles repel each other. So why these two electrons are together in one orbital, since they repel each other? So how it is possible that two electrons are staying together, having same charge? So how the repulsion between the two electrons is minimized? So what about that repulsion between the two electrons if you place two electrons in one orbital? So this can be another question. So to answer this question, beta, we need to know that what kind and what type of motion electrons do. Movement of electrons, movement or motion of electron. So electron has two types of motion. Electron moves around the nucleus. This is one of the motion of electron. Electron moves around the nucleus, right? Similarly, at the same time, electron rotates on its axis. Electron also rotates about its axis. It is identical to the motion of our planet Earth. You are familiar with the concept that planet Earth moves around the sun as well as moves or rotates on its own axis. So this rotation on its own axis is technically known as spin. Okay. So this spin moment or spin motion means movement or motion around own axis. So both this our planet Earth and electron, they spins as well, along with their motion around the center. Like for atom, the center will be nucleus, and for the solar system, the center is sun. So electron moves around the nucleus as well as rotates on its own axis. So the electron rotation on its own axis is known as spin, right? Okay, so the spin motion of electron can be of two types. Electron can make two types of spin. One of the spin is clockwise, can be clockwise, so clockwise spin, and the other spin can be anti-clockwise, clockwise spin. So electron spins as well along with its motion around the nucleus. So the spin of electron can be of two types, so clockwise spin, and the other spin can be anti-clockwise. Now, if two electrons are there in one orbital, like this is the one electron, this is the other electron. So two electrons in one orbital, they spin. Now, these are the two electrons in one orbital, okay? Like I draw orbital, orbital is drawn with the, represented with this box, and the two electrons, maximum two electrons can be placed in one orbital. So those two electrons spins in opposite direction, okay? So one of the spin, the one on the right is clockwise spin. This spin is clockwise spin, and the other spin is anti-clockwise spin, okay? So you know that when a charged particle spins or moves, it produces magnetic field. You know this thing from physics concept that whenever a charged particle moves or spins, it develops magnetic field. So both these electrons are charged particles, but they are spinning in opposite direction. So what happens that the magnetic field produced by these two electrons will cancel each other, because both magnetic fields will be in opposite direction because both charges are moving in opposite spin. So as a result, the repulsion between the two electrons is minimized. Okay, so why electrons moves with opposite spin? This opposite spin minimizes repulsion between electrons. So due to opposite spin, the repulsion between electrons is minimized. The repulsion between electrons of one orbital is minimized. I'm not saying that the repulsion becomes zero. Repulsion will be there, but it will be minimized. So the repulsion between electrons of one orbital will be minimized. And beta, that is the reason why we represent two electrons of one orbital with opposite arrows. These opposite arrows suggest that two electrons are spinning in opposite direction. And why the electrons are spinning in opposite direction? They're spinning in opposite direction to minimize repulsion. So now the answer would be why opposite arrows, because two electrons in one orbital has opposite spin, or they moves with opposite spin, moves with opposite spin, or rotates with opposite spin, rotates with opposite spin. right? And with the opposite spin, the repulsion between electrons is minimized. The opposite spin, the repulsion between electrons is minimized, right? Okay. After discussing this thing, beta, the next concept is that subshells has orbitals. Subshells contains orbitals, and orbitals contains electrons. So now you need to know that the S subshell has one orbital only, like this, and one orbital can accommodate maximum 2 electrons. So maximum 2 electrons can be placed in one orbital. So S subshell can accommodate 2 electrons, and it has one orbital. P subshell has 3 orbitals, okay, like this. These are the 3 orbitals of P subshell, and maximum 6 electrons can be placed here. 1, 2, 3, 4, 5, and 6, like this. Maximum 6 electrons can be placed in P subshell. Now D subshell has 5 orbitals, like this: 1, 2, 3, 4, and 5, and maximum 10 electrons can be placed in D subshell. And F subshell has 7 orbitals: 1, 2, 3, 4, 5, 6, and 7. So 7. So maximum 14 electrons can be placed in F subshell. So you need to know this, that which subshell has how many orbitals and how many maximum electrons can be placed in a particular subshell.